Welcome to The Explainer. Today, we're going to peel back the curtain on one of the most powerful technologies of our time, Transformer AI.
Okay, so let's just dive right in. This entire paragraph you're seeing about talking unicorns, an AI wrote that. And what's so wild isn't just that it makes sense, but how creative and coherent it is. It built a scene, introduced a scientist, and then just dropped this amazing twist. The unicorns speak English. This is exactly the kind of magic we're talking about.
And it's not just about making up fun stories. The very same technology can take a super specific customer complaint from a transformer, which is pretty funny, and translate it flawlessly. What's really incredible here is that it's not just a word-for-word swap. The model totally gets the context and correctly uses the formal German pronouns ihrem and sie, which, is absolutely crucial for getting that professional tone right. This is deep language understanding in action.
So the big question is, how? How is any of this even possible? Well, the answer lies in teaching computers how to actually read, not just seeing letters on a page, but understanding the meaning, the context, and all the little relationships between words. That's the real secret behind the magic.
This is the fundamental challenge, right? To a machine, a sentence like, "I love this," is, well, it's nothing. It's just a meaningless string of characters that, at the end of the day, is all just ones and zeros. So how on earth do you bridge that massive gap between raw data and genuine understanding? The very first step is a process called tokenization. You can kind of think of it like we're giving the computer a special dictionary. Before it can even try to read a sentence, it has to break it down into these smaller, meaningful pieces that it can look up and work with. And these pieces are called tokens. So here's how it works. The model grabs some raw text, say, tokenization is cool. Then it breaks it into these tokens. Now notice how tokenization actually got split into two parts. We'll circle back to why in a second. Finally, each of these tokens gets its own unique number. This numerical form is the language the machine can actually process. And this is where it gets really, really clever. Instead of just splitting sentences by words or by characters, it uses something called subword tokenization. It's the perfect compromise. It keeps common words like is and cool as a single unit, but it can break down more complex or rare words, like transformer, into smaller, manageable parts it already understands. This makes the model incredibly flexible and super efficient. Now, you might be thinking this is all super high-tech stuff, locked away in some secret lab, right? Well, that's the thing. It's not. Thanks to a really vibrant open-source community, these powerful tools are being put into everyone's hands. A huge driver of this accessibility is a company called Hugging Face. Their friendly logo has pretty much become synonymous with making this technology available to everybody, and they've built a whole ecosystem of tools for developers. They provide these incredible open source libraries. You've got Transformers, which gives you access to thousands of pre-trained models. Datasets makes it way easier to work with massive amounts of text data. Tokenizers gives you the tools to do exactly what we were just talking about. And Accelerate helps you train these models on pretty much any kind of hardware. It's the whole shebang, a complete toolkit for building with AI. Okay, enough theory, let's make this real. We're going to use this toolkit to build something practical. A model that can classify the emotion in a tweet. So the goal is simple, but really powerful. We're going to train a model to read a tweet and tell us if the author is feeling sadness, joy, love, anger, fear, or surprise. And to do this, we'll use a large data set where thousands of tweets have already been labeled by humans with one of these emotions. All right, first things first in any data project, you have to understand your data. This chart shows the distribution of emotions in our training set. And you can immediately see that joy and sadness are the most common, while surprise is way less frequent. This is really important because a lopsided dataset can sometimes lead to a model that's great at recognizing the common emotions, but not so good with the rare ones. Okay, now this is what's so interesting. This is what happens after the model has processed all that text. These plots basically show how the model is thinking about the tweets. And get this, without ever being told which emotions are similar, it just figured it out. See how sadness, anger, and fear are all clustered in a similar space, while joy and love are off in another little world? It's learning the underlying meaning of the words all on its own. So because the model has already built this rich internal map of language, we don't need another complex AI to finish the job. We can now train a very simple classifier right on top of these powerful representations, and it'll be able to accurately predict the emotion of a tweet it has never ever seen before.
This is all amazing. But the thing is, this technology is moving incredibly fast. It is already expanding far, far beyond just understanding text.
The same fundamental ideas of understanding context and patterns, the stuff we just saw with language, are now being applied to all sorts of data. So, for instance, instead of tokens being parts of words, they can be patches of an image, and that allows an AI to see. In the same way, it can see patterns in computer code to help developers write programs. It's the same core concept of learning relationships, just applied to totally different domains.
But of course, this incredible power comes with its own set of pretty big challenges. These models are absolutely massive, so making them smaller and faster is a huge hurdle. Just deploying them is really complex. And most importantly, we have to ensure they're safe and reliable, making sure they behave as intended, especially since they're trained on vast amounts of internet data. At the end of the day, this technology is a mirror. It reflects the language and the data that we feed it. And that leaves us with a final crucial question to think about. AI is learning our language, so what do we want to say to it?